Right now, somewhere in the world, a baby is experiencing something you will never remember. Tomorrow it will be gone. Forever. You have thousands of memories from childhood, hundreds from adolescence, but from your first 3 years of life, the most transformative years you will ever live, you have almost nothing. Not because you didn't experience anything, not because those moments weren't important, but because your brain was designed to forget them. This is called infantile amnesia, and it's one of the strangest features of human consciousness. You lived through some of the most critical developmental moments of your existence, and your mind erased them completely. Your first word, your first step, the face of the person who loved you most, gone. And there's a deeply counterintuitive reason why this happened. Most people assume memories just form like photographs. You experience something, your brain takes a picture, and it stays there. But that's not how memory works. Memory is a story your brain tells itself, and babies can't tell stories yet. That's the key. In 2013, a researcher named Peterson conducted a landmark study on childhood memory. She followed children from infancy into adolescence, tracking what they could remember from their earliest years. The results were striking. Children who experienced dramatic events, a serious accident, a hospital visit, an injury, could recall those events vividly at age 4 or 5, but by age 8 or 9, those same vivid memories had vanished. Not faded, vanished, as if they never happened. Peterson discovered something crucial. The memories hadn't disappeared because the brain forgot them. They disappeared because the brain had rewired itself. Your brain at age 2 is not the same brain at age 8. It's not even close. Here's what's happening inside your head right now. Your hippocampus, a seahorse-shaped structure deep in your brain that's responsible for forming new memories, isn't finished developing until you're about 3 or 4 years old. More specifically, the neurons in your hippocampus don't form stable connections until then. Your brain is constantly pruning synapses, cutting away connections that aren't being used, strengthening the ones that are. This process is called synaptic pruning, and it's absolutely essential for learning. Think of it like this. A newborn's brain has more neural connections than an adult brain. Far more. Roughly twice as many. But most of those connections are useless noise. They're random firing patterns that don't mean anything. So your brain does something counterintuitive. It throws them away. Over the first few years of life, your brain aggressively deletes roughly half of its connections. And in the process, it erases the memories that were stored in those connections. But here's where it gets stranger. The memories don't just disappear randomly. They disappear in a specific order, based on how recently they were formed and whether your brain thinks they're important. Memories from your first year? Almost completely gone. Memories from your second year? Mostly gone. Memories from your third year? Starting to stick around more, but still fragile. The reason is that your brain hasn't developed the biological infrastructure to store long-term memories yet. A memory needs to be encoded in a specific way to last. It needs to be consolidated, reinforced through repetition and emotional significance, and consolidation requires a fully developed hippocampus. A 2-year-old's hippocampus is still under construction, but there's another reason too, one that has nothing to do with neurobiology. It has to do with language. In 2009, a psychologist named Katherine published research showing that children who developed language skills earlier actually lost their early childhood memories faster. Not slower. Faster. This seems backwards until you understand why it's happening. Memory and language are deeply intertwined. Your memories aren't stored as pure experiences. They're stored as narratives. They're stories. And to create a narrative, you need language. You need to be able to think in words, to sequence events, to give them meaning. A baby can't do that. A toddler is only just learning. When you can't narrate an experience to yourself, when you can't turn it into a story with a beginning, middle, and end, your brain doesn't treat it as a permanent memory. It treats it as noise, sensory input that doesn't need to be filed away, so it gets discarded during synaptic pruning. This is why you remember almost nothing from before age 3, but your older self has vivid memories from age 5 or 6. By 5 or 6, you had language. You could talk to yourself. You could narrate your own experience. And once you could do that, your memories started sticking around. There's something almost cruel about this design. The period when your brain is growing fastest, learning the most, absorbing language and social cues and motor skills at an impossible rate, that's the exact period when your brain is erasing its own records. You're building yourself, but you're not keeping the blueprints. But here's the thing. This isn't a bug, it's a feature. Your brain is doing something essential. It's clearing out the clutter, it's making room for the memories that matter. If you remembered every single moment from infancy, every sensory experience, every random firing of neurons, every mundane instant, your brain would be overwhelmed. You'd be drowning in useless data. Instead, your brain has learned to be ruthless. It keeps only what it can encode as narrative. It keeps only what you can talk about. This is why infants and toddlers can learn so fast. Their brains aren't bogged down by the weight of old memories. They're living almost entirely in the present moment. They're absorbing language and motor skills and social patterns at a rate that will never happen again in their lives. And the price they pay is that they won't remember any of it. There's evidence that this process isn't universal across all species. Rats don't seem to experience infantile amnesia the way humans do. Neither do some primates. But humans with our massive prefrontal cortex, our extraordinary language abilities, our capacity for complex narrative thought, humans are especially vulnerable to it. The more developed your language centers become, the more aggressively your brain seems to prioritize narrative memory over raw sensory memory. So right now, a baby somewhere is living through moments of pure presence, perfect perception, a world of sensory input unfiltered by language, uninterrupted by self-consciousness, unmediated by narrative. And tomorrow, it will all be gone. But the learning will remain. The neural pathways will be strengthened. The language will have sunk in. The developmental milestones will be crossed. Your baby self built you. And then it erased itself from memory. This is the strange bargain of human consciousness. We gain narrative, we gain story, we gain the ability to understand ourselves. But we lose the raw purity of experience. We lose the present moment. And once you're old enough to remember your own life, once you can narrate your own experience, you can never go back to that state. You can never truly know what it felt like to perceive without language, to experience without story, to be alive without yet being a self. That baby who can't remember being a baby? In a few years, that baby will be you, telling yourself stories about who you are, and you'll never know what it was like before the stories began.